Hello again. This is Unit 4. Unit 4 will be mostly consolidating what we've learned in the last 3 units, particularly the last unit with derivations. There'll be a little bit of new material, but not much. So I'm going to talk about new material in the sense we'll be talking about more derivation strategies, but not much more in the way of defining our logical systems. So I'm going to, in this video, talk about mixed derivations. In the next video, I'll talk about derivation strategy. And then after the homework is due, I'll post a video reviewing some of the more difficult homework problems. So mixed derivations. What's a mixed derivation? Well, so here's an argument for which we can do a mixed derivation. So we're going to first hop over and actually do the derivation of the argument, and then we'll see why we call it mixed. So our argument is P, and if P then Q are our premises, and the conclusion is if not Q then R. So we say show if not Q then R, and the first thing we want to do, no matter what, always is we do what? We make an assumption, and if we can, we make a conditional assumption. So we'll say assume CD, and we will be assuming the antecedent. So there it is, not Q. Now, we could go ahead and say show consequent, and then we would again want to make an assumption, and that would be assume ID. And once we completed this little subderivation, we could say 3CD. We would have the consequent. But that's not what we're going to do, because we can complete this derivation more quickly. So let's bring in our let's look at premise 2 first, actually. So 2 and 3 can interact, right? 3 is a conditional, so we can do modus ponens or modus tollens with it. To do modus ponens, we would need the antecedent P. To do modus tollens, we need the negation of the consequent. The consequent is Q. The negation of the consequent is not Q. We have not Q on line 2. So we can say 2, 3 modus tollens, and that gives us not P. Now, if we bring in the first premise, we say, oh, look, that's a contradiction. And what can you do with a contradiction? You can box and cancel with indirect derivation. Now, what's happened here is this is a mixed derivation. We start with a conditional assumption, and we conclude with box and cancel with an indirectly. That we could do this was implicit in the way we spelled out the rules for boxing and canceling. If you remember, when you box and cancel, you only cite, if it's boxing and canceling with CD, you only cite the line in which the consequent occurs. You don't say anything about the assumption. And if you box and cancel with ID, again, you just cite the lines on which you have a contradiction, and you don't refer to the assumption. And so built into that is it doesn't matter what the assumption is, and so you can make a different kind of assumption. Now, the reason why this is okay is that, well, there are 2 reasons. In this specific case, it's okay. This is a truth-preserving argument. It's a valid argument if the premises are true, and so is the conclusion, because of the way in which we understand the conclusion, and the way in which and in particular, the way in which we understand conditionals. How do we understand conditionals? Well, for our understanding of the arrow, it turns out that if the antecedent is false, then the conclusion is true, and then the conditional is true. And what we've shown is that if the antecedent is true, then a contradiction is true. And so if the antecedent is, but that means the antecedent can't be true, not Q cannot be true, because if it were, a contradiction would be true. Not Q can't be true, and so this conditional must, given that the premises are true, have a false antecedent, and therefore this conditional must be true. Now, I will be talking later in chapter 2 about why in our system a conditional with a false antecedent is true. There's reasons why that's a little bit weird, but for us, if a conditional has a false antecedent, we're going to treat it as true, and what this derivation has shown is that if the conditional's antecedent is true, along with the premises, then there's a contradiction, meaning that if the premises are true, then the conditional's antecedent must be false, and therefore the whole conditional must be true. So let's go back to our little slides and resume. So there's our argument. So in a pure derivation, the assumption matches the method. So you start, if you have an assume CD, you box and cancel with CD. If you have assume ID, you box and cancel with ID. In an impure or mixed derivation of the kind we just did, the assumption does not match the method. So you would say assume CD and then box and cancel with ID, and indeed that's the most common form of mixed derivation. So it turns out that there might also not be any assumption. So it turns out that well, you might wonder, do mixed derivations preserve truth? Is this a good way of establishing it? You say, I did a mixed derivation of this argument. Is the argument valid? Is it the case that if the premises of the argument are true, the conclusion is true? I did a mixed derivation. Well, in fact, the answer is yes. The reason is that whenever you have an impure derivation, a mixed derivation, you could expand it into a pure derivation. And so what you know is, look, if I think pure derivations are okay, and I have an impure derivation, well, given that I have an impure derivation, I could have done a pure derivation, and pure derivations are okay. So if I did a mixed derivation, then I'm okay. We're not going to establish that during the class, however. We're just going to say, yes, the way we've laid it out, in fact, you can do mixed derivations, and that's just fine, and there's no problem with that. And so that's the way in which we're going to proceed. Mixed derivations are okay. So that's it for this brief video. In the next video, I will be talking in more detail about derivation strategy and how to figure out how to construct derivations and doing more derivation examples. So I will see you there.